Welcome to the College of Information Studies GEM Analytics Industry Speaker Series, Game Entertainment and Media Analytics. And we've got a special treat today for a talk from David Landy from Netflix, who's going to talk about how data used at a streaming company, Netflix in this case, can be used to shape the future of content. David's going to present a broad overview of how streaming data is distinct from other high data businesses like gaming or financial services. And the primary focus of the talk will be on interplay between understanding user behavior with models, the challenges of translating those models into actionable insights for non-technical stakeholders, and the ethical questions around working with large private data sets about individual taste preferences, with several examples drawn from practical issues in applying data to understanding the impact of series and films on members. And David is going to highlight roles that different perspectives such as economics or psychology or varied life experiences can play in improving data science. So as an introduction, David Landy received their PhD in cognitive science and computer science in 2007, was a professor of psychology for 10 years at University of Richmond and Indiana University. David specialized in human ways that problem solving and mathematics leverage visual and spatial systems. In 2018, David moved to industry and took a position as a senior data scientist at Netflix, focusing on product innovation experimentation. And in 2020, they moved to content data scientist and currently is focusing on interpretable psychological models of member taste. So before I hand it off, I'm just going to share one note. If you have questions, we do have a Q&A panel, so you can add that into the Q&A panel or into the chat. We are going to listen to David. After David speaks, I'll share some information about the Master of Professional Studies in Game Entertainment and Media Analytics, and then we'll answer some questions until the end of the hour. So David, thank you very, very much for coming in and sharing your thoughts today.
Sure, absolutely. Happy to be here and happy to help. And thanks everyone for coming and listening. And please, I'm going to present some slides and talk from a very high level about my experiences, primarily at Netflix. And but please do, or actually, I guess, David, I should ask you, I don't quite know the format here. Are people welcome to ask questions during the talk? Do you prefer people wait until the very end? Or how should that go?
I think it'd be preferable if you've got a story to tell to kind of wait till the end. But if you see a question pop up and it's something that's relevant to what you want to share, I'm not going to restrict you from answering it.
All right, perfect. Then I will go ahead and talk a little bit about what it's like to work at Netflix, or what it's been like in my personal experience, and talk through some of the issues that David laid out. So I want to note a little bit about me. First, I am a senior data scientist at Netflix. I have been for almost 4 years. Like a lot of people in tech, I wear a lot of different hats. So just to mention in passing, I'm Chief Strategy Officer for a tech startup in the ed space. I still have an affiliation with Indiana University, where I was a professor for several years. I'm also the Director of Data Science at a hair salon that I'm a part owner of. And in fact, I mention that because many of the models that you learn in a data analytics context work across many different fields. In fact, I was trying to think, I can't think of any models that I've used in all 4 of these contexts, but I can think of many specific models that I've applied in at least 3 of them. So these things really do cross over, and kind of what you learn when you learn data science is a way of thinking and a way of approaching the world that just ends up getting applied over and over again. So I wanted to mention that in passing. Obviously here I'm going to focus on my experience at Netflix. So I've been there for almost 4 years. And I have worked across a few areas of data science in the business. I spent my first couple of years mostly on what we call the product side. That means the website, the recommendation system, what we give to members and what we show them. And then about 2 years ago, I moved over to the content side. What we do on the content side is think about how do we help our showrunners and our strategists who are buying content. How do we help them understand content performance? So I'll go into detail on that piece later, but I just wanted to mention kind of the experiences that I've had. I also want to mention some very boilerplate caveats. The first is we use data at Netflix in so many different ways. I'm going to focus on some of these ways, but a very small subset. I also want to say I show a little bit of data in here, not really, but it's very much faked and simulated, or just not quite representative. So any data in there, just want to highlight that fact. I also wanted to mention, I'm going to talk about data science, data science, data analytics, in my experience, I'm sure in the GEM program, you talk about distinctions here. I'm very much using them interchangeably. I think of them as very similar in their perspective, maybe a little different in emphasis. But so most of what I'm going to say, I'll say data science because that's my job title, but I very much include data analysts who are often doing the same work and vice versa. And then, of course, I'm talking for myself, not talking for Netflix. Okay, so at a very broad view, then I want to talk about how we use data to help streaming be better. And I said I'd highlight a bunch of different ways that this is true. So here are just a small set, but there are so many of them. First of all, one that you might not think about, but happens a lot, is minimizing data throughput, right? We ship a lot of data at Netflix to a lot of different places. In many places, those data costs are very high. So we need to think about how do we minimize the amount of data we are putting onto someone's device or putting through somebody's potentially paid by the megabyte data stream. We also think a lot about caching. You know, that thing that happens when you're watching Netflix and you get a little, or watching a service, whatever service, and you get a little like buffering symbol, right? We at Netflix got very upset with that a few years ago and worked very, very hard to make sure that we almost never have that happen. And that's a big data science endeavor because it's understanding just when are your members seeing that is already a challenge. And then understanding why is a big kind of data science problem. I want to mention like studio operations management is a really exciting place you can use a lot of data. A lot of studios are very old school in the way that they think about, well, to make a title requires coordinating a lot of different people who don't necessarily work for your company. Some of them do, many of them don't. And you've got to get them all into the rooms, the right rooms at the right times, right? And understanding how to manage that workflow is a big area where a lot of data science gets used. I think more famously, more familiarly, you know, we do A/B testing. We test different versions of our algorithm, of our UI, of how we message, right? People are familiar with that. Another way you can use data to help a streaming business is to buy or sell that data, right? We're getting valuable data in our company about what people like, what they want to watch, what they want to see. I'm crossing that out because Netflix does not sell any personal data or share any personal data. At this point, we also, in my personal experience, you know, we buy industry data sometimes. We buy like Nielsen ratings or things like this. I honestly basically never interact with any of that data. So it's a pretty limited part of what we do. And that's a particular fact about my company and how we operate. I also want to mention, we have a Netflix tech blog. It's a great place to see in-depth kind of descriptions of a lot of these models and a lot of these approaches and some of the really exciting work people are doing out there. But okay, turning to the question I want to focus on, it is how do we use viewing and streaming data primarily to help us make good content decisions? One option, which you'll read a lot about, actually, if you look at how Netflix uses content, a lot of people say we use big data to make our content. There are a couple of efforts out in the world that exist where people have tried to use machine learning to directly make content. They are terrible. It turns out we do not have at this point anything like the capacity to say, oh yeah, you know what, in minute 23, these characters should kiss and that would be great. We just, it's maybe someday, but at this point we're nowhere near that, right? Our content is always going to be made, well, I say always, who knows what the deep future holds, but for now, our content is made by people. And then, so that leaves us with a more limited option, which is how can we make that content better? And how can we buy better content as a company based on what we know about what people want? So we're really using data to leverage production markets. That's the business perspective on what we're doing. And better content from this perspective basically means that our customers are going to like it. And either our competitors don't know that people are going to like it, or our competitors have a particular market base where they won't like it, right? So that content then is valuable to us. And either our competitors don't find it valuable so we can get it cheap, or our competitors don't know that it's really valuable and we get it cheap. And that's a big place where data science comes in, right? Is helping us understand our customer base better than other people do. I'm putting a big asterisk there by our customers are going to like it, because one of the big lessons for us has always been something that I like, you might hate, something you love might leave me totally cold. And so customers is always very much an individual experience or aspect. And I guess I'll also mention, we're trying to do this job well, but it's always a probabilistic game. So I could not say the number of our big hits that are very famous that going into it, we thought, oh yeah, that's going to be a pretty mediocre title. It'll do fine. It's a game that's very, very hard to play. I want to talk a little bit about why this is such a hard game to play and why we have such a challenging context in streaming. I feel very jealous of people who work in gaming and other kinds of places like this, because if you think about how a machine learning model works, it's always, you take an action in your model, you have some environmental response, and you get some reward signal, and that's what updates your model. It's always a feedback loop between taking an action and getting some kind of environmental reward. And that's the basics of how you act better in the world, right? For us, an action means creating content or editing content or creating some kind of piece of an asset. And then the reward is when people watch that content. But now I want to just take a second to think about this as a data problem, because I think it's really fascinating. The problem goes something like this. Viewing happens at one moment in time. One moment might happen over a few months. Then that data gets ingested, right? By our company, we learn some lessons from it. We come to understand something from it. And then we're going to greenlight new shows, right? We're going to actually make some new show. And then there's a long sequence of time in which we produce that show. And then after we produce the show, once the show's basically ready, we still have to do things like make the box art that you see on the webpage, make the synopses, make all the right assets, get our marketing plan in place. And then new viewing happens. So the time lag is incredibly long, right? So it's actually about 2 years typically from one sort of lesson we learn, one data set we collect, to collecting the next data set of shows that we made on the basis of those learnings. Over those 2 years, so many different things happen. And we see this over and over again. We often have titles where when we bought them, we thought that they would be great, but then our member base changes. And it turns out actually we're not as competitive in a particular space as we thought we'd be, or we have tons of new members we want to appeal to. This certainly happened for us. There was a period of time I remember when we were super interested in titles like Okja in Korea, and we thought we were going to really be struggling there. And then more, in the 2 years basically since that time, we've had Squid Game, we've had a bunch of really big hits in Korea, and it's really shifted how we think about things, but we're producing things on the basis of our old mindsets. So we're always producing things on the basis of the mindset we had 2 years ago, in a sense. Also, yeah, I said new markets, right? So sometimes we're opening up in new markets, sometimes we're just expanding in new markets. So we have new things. Obviously, over that time, new competitors can arise. And that really matters because what people are viewing on our service is a function of what they can't view on other services, right? It's always sort of competitive landscape that we're thinking about. So we're always comparing our data to that outside option. And then, of course, tastes can change, right? So 10 years ago, there were a bunch of shows like Alexa and Katie. There were these like sitcoms for kids, for young, like young teenagers, pre-teenage sitcoms. Disney made a bunch of them. We made a bunch of them. Very few of them get made these days by anybody. And one interpretation of that is that taste is changing across time and people don't want the same kinds of content that they used to want. That can easily happen over 2 years. And yet we're going to be putting out the shows we thought were good 2 years ago. So I'm spending a lot of time talking about this because just thinking about the data is the thing that we're constantly working with and just the experience we're having. Second thing that I want to point out is the sort of basic, so sorry, that's the first challenge, big time lag. I've already said it, so I'm jumping past it. The basic data setup, just want to point to, we have titles, we have members. There's other stuff going on, obviously, but like this is a good starting place to think about it. We have titles that have characteristics. They might be in a particular language. They might be a movie or a limited series or a season 1 or a season 3, right? And they might be coming from a particular genre. There's other characteristics titles have. But then members have characteristics, and mostly we stick to characteristics that we need to know about a member to run the service. So that's things like what country they're in, right? Which affects what content we can have a license to give them. whether they're an active member and for how long, what their viewing patterns are, right? We're serving them the content we're looking at, and then kind of what plan that they're on. So there's different kinds of characteristics there. And then the basic issue is that viewing connects those. So I'm gonna talk a little about the basic data setup at any streaming service, right? This is wholly generic because it's just the nature of the data. What we have is we have particular accounts, particular collections or conglomerates of people watching particular titles at particular times. And I want to point to, just in this imaginary thing I put here, we have a couple titles Inventing Anna, we have a couple members who are watching Inventing Anna and Don't Look Up. Notice that that first account watched 30 seconds of Inventing Anna and stopped. And you might think, oh, simple inference, they didn't like it. They thought they might like it and they didn't. But now you look a month later, and on March 30th, so I put a date in the future, that same person came back and watched 45 minutes of it. So what does that mean, right? And in fact, what might happen then in the future with that content? What does that suggest about how they feel about it? This is our basic data layout, and this is our basic data question, right? What in what they watched indicates something about what they like and what they don't. And this is the second lesson, and it's why I'm so jealous of people who work in gaming, because in gaming, you get a really tight interaction a lot of the time between what a person does in their interaction and what happened. Right? Did they walk down that hallway? Well, if they saw it and they wanted to go down it, they probably walked down it. Do they, attack that creature? Well, probably if they wanted to. Everything is very dynamic and responsive. Well, in content, in streaming video, people do things all the time. They pause it, they start it again, they switch devices, but it has nothing to do with your content. Almost all of the data, which is pretty sparse, right, is irrelevant to your goals. People paused your content because they got hungry or because the phone rang, right? They got a text message they wanted to respond to. People binge our content while literally asleep, right? And we'll be like, oh, they must have really liked that content. They stayed up all night watching it. And then the next day they watched the same episodes. Well, right, they were asleep, right? Also, people watch content in a lot of different contexts we're not aware of. So with friends, with family, often both. And I'm just kind of pointing to some of the challenges that we think about. So what's going on when people watch our content? Oh, on the asleep side, actually, I'll say this is an interesting thing because we often think about content like Great British Bake Off is one that we suspect people are often watching to go to bed. It's hard to say, we don't know, but it affects potentially how we measure the viewing value. And of course, that might be really valuable because helping people sleep is a great thing to do, but it might not be the same great thing as keeping someone riveted in a particular piece of content, which people also do with Great British Bake Off. But in terms of watching patterns, I want to give you just one example from my personal life that I have used in conversations at Netflix as we think about who's watching what content and what does it mean. So this was my viewing of Squid Game. I really love Squid Game. I don't know how many of you have seen it. It fits my particular taste profile. So here's what happened. I watched the first couple episodes on my phone on a plane. And then I watched another episode while I was traveling on my laptop. And then I was like, this is great. And my daughter, who's 15, was like, she's going to love this content, right? So I got her to watch it. So my daughter, who I marked with a D, which is tricky since my name is David, but D is my daughter. My daughter watched it on her laptop. And I was like, you got to catch up with me. So now we have two profiles on our account watching the same episodes over. And then we watched together on our TV the next several episodes. During that time, we found out that one of my daughter's friends was watching Squid Game and loved it. So we were like, oh, you got to watch it and catch up. So she binged like 4 episodes of it all in a row so that we could all finish the season together, which we did again on my TV. So if you try to understand this viewing pattern from the perspective we have, which is accounts and devices, you can see you get this very chaotic kind of pattern. And you might conclude, for instance, that my daughter really didn't like it. She watched 3 episodes and quit. She didn't, she watched it with us. And same thing with her friend who binged a whole bunch of it and then just stopped, right? Well, she didn't, she watched it with us, right? And so this is some of the data complexity that we're constantly dealing with as we try to understand who liked our content and in what way did they like it, right? What are they doing with it that might give us a hint as to what they want 2.5 years from now. Okay, so that's our sort of data layout. And I'm going to turn for a minute to talk a little bit about the kinds of stakeholders that we think about when we're making decisions at Netflix. And there are basically 4 stakeholders that are really important. And I just want to lay out It's a lot of things you can do in data science and data analytics that are completely fun, really interesting, and totally pointless. So you're always thinking when you're doing this work about who are my stakeholders, whose interests am I serving, and why am I doing it? And in fact, importantly, they're the ones that are pointless. They're also the ones that are damaging, right? And any analysis we do is going to help some people, and many analyses we do are going to hurt some people. So we always want to be thinking about that and weighing it and understanding it. So 4 basic stakeholders I'm going to focus on. The first is our customers. The basic need our customers have, we think, is they need great data, great content, and they need it to be made well. That's straightforward, except of course for what great content is and for whom. Also, our customers have an intrinsic interest in data privacy and confidentiality and not having their viewing exposed, right? We think about this a lot because sometimes content viewing is extremely personal, and sometimes that exposure can be meaningful, right? We're not dealing with bank account information, but we are dealing with things people are doing privately for themselves sometimes, and sometimes very performatively. So we think a lot about that kind of data privacy. In my work, a lot of what I'm doing is thinking about member taste, and intrinsically that means labeling individuals, right? Even if what we're saying is this person, this account, this random account, I say person, but it's going to be a collection of people. And of course, we don't identify them, but even just saying this random account number is really, really like sci-fi. Well, what we've done is we've labeled that account in some way. And so I just want to highlight, there's always a concern. We think about this a lot. Like, what does it mean to say that person likes sci-fi? What does it mean to say that person really likes content that was produced in Japan or anime or something else, right? We're intrinsically labeling people. And then the final concern that we think our customers have is fairness and equity across groups. And by fairness, I mean, people are getting roughly comparably good products. And by equity, I mean, really like the outcomes end up being, equal, right? People are getting equally good products. I'm going to come back to that in talking about the models, because that's often a very, very hard thing to achieve. I just want to point out there are a bunch of ways we might want to achieve that. And in our case, almost all of those are things we don't know. So we know what country people are watching in, and we have to for licensing reasons and for delivery reasons. We don't know anything about our members' gender identity or race or ethnicity or socioeconomic status, et cetera. And yet we want to be equitable across those divisions. So that's an extremely challenging goal that a lot of data science groups are dealing with right now. And I think nobody's probably got it right yet. But I want to highlight it as a really important goal that we think about a lot, especially when we're engaged in the process of labeling these random accounts in some kind of way. Okay. So I will move on now to needs of the businesses. First of all, businesses need money, like obviously, right? A business fundamentally is trying to create value for its shareholder. That's a great thing. That's what our businesses are all to do. None of these are nonprofits, but they have very different ways of achieving that. And I want to highlight that because that actually really does affect, I think, the ways that we think about things. At Netflix, we charge our customers directly. So it's a lot of decisions actually get very easy at Netflix because we charge people, they send us money, we try to make good content for them, and we have a very direct relationship. A lot of other companies are working on the basis of advertising. So for instance, Tubi is advertising to its members. And so it can say, okay, we think these members are interested in this kind of advertising, and they can actually do some nice differential charging of companies to produce some of that money. Peacock also charges directly. I love the model of Tubi. I know some folks at Tubi, and they have a super interesting data problem because Tubi is a streaming service in which you can watch content without paying, but also without logging in. So they have viewing data and they can do some things with that, but they actually don't even know which account is which. If you come back to watch the same show again, they don't know that necessarily unless you sort of voluntarily tell them. So everything is happening anonymously. And that means they have this super challenging question of figuring out what do you, who as far as we know has just watched this one title, what do you like? And what advertising might be valuable for you. And then other companies, Disney recently announced that they're exploring selling viewing data to retailers. So that might be something they do or don't do. I have no idea. but that is something that companies can do and can think about, is do we sell that viewing data to other retailers who might want to sell other products in other places? Another big distinction in these businesses is, are they global or are they regional? So most of the companies in the US are fairly global in their availability, but other companies like Sky or Viaplay in Europe, like Hotstar in India, are not. They're really centered on one particular market and really super serving that market, really doing that well. And for that, you need then different understanding of your customers. And then similarly, some businesses are really focused on broad all of TV, while some are focusing on particular kinds of content or particular quality levels or particular formats. So there's big differentiation there. Then I'm going to mention, and this kind of gets into the meat of what I want to talk about, the needs of our content producers. So a lot of what I think about, my primary stakeholder really is day-to-day people who are trying to produce or buy content. So this can mean content executives who work for a streaming service. It can also mean talent external to the service, right? So directors, writers, showrunners, and also camera crew and, people who organize the projects, right? Do project management work on these things, people who work in all kinds of spaces, video editing. Like there's so many people who get involved in making a particular title, and they have needs about their content. Really what they need, though, I think comes down to three things that are interesting from a data analytics perspective. The first is actionability. People need simple, clear insights they can do something with. They need them to be accurate, sure. But even more than that, they need them to be actionable. They need them to be something they can do something with. They also need results that are insightful, right? A lot of things when you watch a TV show and it's really bad, you kind of look at it like, oh yeah, that's bad. That thing happened and it wasn't interesting. And in some sense, a lot of these insights are obvious. Another one is sometimes, you might look at when people drop off a title, like stop watching. And what you might expect, hypothetically, is that people drop off a lot, say, during really violent scenes. But if you come back and you say to a content producer, oh, people really watched your title right up until the really gory scene, your producer's going to be like, yeah, I know. Right? So you need, in some sense, to be producing insights that are not obvious as well as accurate. And then the last thing I want to emphasize is autonomy, which I think is one that comes up a lot in the sort of human element of understanding these data models. My favorite example of it is we've talked to a couple of content executives who are really interested in information. They're like, look, what I want is a lot of information from you. What I don't want is data. And it's a really interesting moment as a data scientist because I thought information was data. But actually what they're saying is very sensible. What they're saying is when you tell me what to do, it's not useful. Because often it just doesn't make sense. It doesn't fit my context. I don't know how to do it. When you tell me about what I'm doing, that's useful. Right? That helps me make a better choice. And that's what we're fundamentally trying to do. We're not trying to tell our content producers what to do at all. We don't think we know. What we're trying to do is give them information that makes them better at what they do. So I found that a really interesting distinction, information versus data as a thing to be desired. In passing, I'm going to mention we have internal teams doing lots of stuff with the kinds of data sets we produce. What they often need, these are people producing code, they're people doing A/B tests, they're people coming up with new ideas for how our platform could work. And they often need really accurate models and really actionable models, but they don't necessarily need them to be sort of simple and clean in the same way. So often what they want is more of a mix of accuracy. All right, I have just a few more things I want to hit and talk about in my experience, but really what I want to do now is integrate some of this and put it together and talk about how it plays out when we're actually thinking about data sets and models and modeling approaches. And I hope this is interesting for people thinking about starting a career in data science and maybe with some amount of background. I'll try to keep it very basic, but very high level at the same time. So let's go back to the data. Basically, if you sort of eliminate effects like people going to the bathroom, people pausing your content, people going to work, and other interruptions, you often get to a viewpoint that looks something like this. You have a big matrix, basically. You have members and you have the titles. And you say 1 if the members watch the title and 0 if they haven't, or maybe you look by how much of the title they watched or something like this, but it's basically a big matrix of numbers. And that, in that sense, is exactly the same that we get when we go to the hair salon and we look at customers who have had services done at times, or it's other things like this, right? It's a very, very common kind of layout to think about. And because it's a common kind of layout to think about, there are lots of standard techniques. And what I'm going to do is talk a very broad brush about these techniques. I think this is a really big thing that you need in data science is it's often important to have a wheelhouse of techniques you can execute well. But even more important is understanding the implications and properties of a wide range of models so you can choose them well. Right? A lot of times these models will get you very similar results or the differences are important, but often the differences are in how these things can be used. So a bunch of different techniques. Some of them are very old school, like matrix factorization or topics modeling, what I'm calling linear methods, because what they try to do is in some way treat this data as the result of intersecting separate processes. Right? Matrix factorization will get you a bunch of dimensions of taste, for instance, that will best explain your data. And those dimensions of taste will be like a direction in some high dimensional space. There are also nonlinear methods that yield more complicated structures, but are similar in the way that they're bottom up. They're trying to discover structure in the data. Deep neural networks are like this. Decision trees are like this. Clustering techniques are often like this. They're not necessarily trying to decompose the data linearly or bilinearly, but they're trying to make some kind of structure in it. These are all great methods. Honestly, we use all of them in lots of places. They have a lot of strengths. One is like they have lots of discovery. You find things that you didn't expect all the time in these models. And they're often very, very, very accurate, right? If you really want to predict what someone's going to watch tomorrow, these are great methods to use. There are also a bunch of concerns with them. And actually over in the content space, we've ended up finding them to be very, very hard to use in practice. One reason is that they're not very actionable. If you think about these clustering models, right? Clustering models try to put, say, titles together when similar conglomerates of people have viewed them, or similar people similarly positioned in some kind of reduced viewing space have viewed them. Well, then you have to look at what you got. You have to look at the dimensions you got. You have to look at the clusters you got and try to make sense of what they are. And what that means in a sort of simple view is you're coming to a content exec and you're saying, you know what we really need? We need more of these. And then the content exec says, what are these? And you say, well, you know, it's like these 30 titles. And your content exec will look at it and say, some of those are Polish, some of those are Korean, that one's a comedy, that one's a romance, and that one's 10 hours long. What is this category? And you say, well, similar people liked this stuff. I'm being a little silly about it, but this is the kind of conversation that can happen with these, and it just ends up being so very, very ineffective because they can't go out then to their community and say, oh yeah, give me some more of those, right? There's just no way to have that conversation carry forward actionably. They're often, for the same reason, actually not super insightful. Even if they're very accurate, it's hard to know what you're being accurately told, and it's often hard to distinguish noise from really solid signal. And especially the kind of noise that really concerns us is usually not random noise in people watching. We have so many people watching, we don't have to worry about that. It's random noise in what particular titles we happen to have made and when, right? So it's random noise in what countries those were released in. And those will create real structure that just isn't the structure we're interested in. And these models often make it very hard to see that. And then along the same lines, they often produce a lot of invisible inequity. The most obvious example of this that I've run across is some really nice work that was done by some Google teams a while ago, just looking at how well Google searches work for people who use it a lot and people who don't, and people who use it a lot to search for common things and people who search for uncommon things. The very nature of these methods is that they're finding the common patterns and they're emphasizing them, which means if you're in an uncommon behavior pattern, these models work less well, right? And that in a way is trivial and it's inescapable, but it's a huge problem, especially because being weird in what you want to watch is often an indicator that you are doing something non-standard in the rest of your life. And those are pretty much always the things that we want to protect, right? Those are who we want to serve really well. And we'll make sure we're serving really well. And yet our models are intrinsically bad at doing that. And really crucially, these bottom-up models are often very bad at finding that. Okay, so the other kind of class of models that you might think about are these top-down models. These could be like multi-level Bayesian models, or they could be like good old-fashioned linear regression or agent-based models or things like this. The profile, I would say, of those is you get lots of discovery. You find out lots of new things. They're often, oh wait, whoops, excuse me, no, different list of strengths. I was like, that's not the right strengths. You do not get lots of discovery. Exactly the problem with these. I'm sorry, my slides are a little goofy here. So let me say, I clearly copied and pasted wrong. The strengths of these top-down models are you get really clear ontologies. You know what you're talking about. And because you know what you're talking about, you get high actionability. And because you know what you're talking about, you often get very visible inequity, right? They're really good at surfacing. Oh, actually, look, here's this group that we've identified, this group of titles we've identified, and we're not doing as well with them. We can see that, right? They aren't so good at fixing inequity. And I think that's part of where we are as a data science community, is trying to figure that out, but at least they're making it very visible. The concerns we have with them are they're often slight performance decrements. These models aren't as good. And the other bigger problem is they're often not super insightful because you don't find things that you're not looking for, right? That's the very simple version. So what we've actually done really successfully, I think, over the last few years is focused a lot on a process where we data scientists use bottom-up models to discover groups. We label them, we understand, oh, there's this class of titles. And then when they make sense, we actually build top-down curated models that incorporate that information, but are highly structured. And then actually, these are what we give out to our business stakeholders, to our content execs, and for the most part, to some of the more applied analysts who are using these models. And that way we get kind of a best of both worlds. We can do a lot of discovery from our bottom-up models, but we aren't exposing the weirdnesses of that discovery to our broader community. I want to point out, building that top-down curated model requires a really broad set of skills, not just data science skills. And in fact, most of the value we're producing then comes from a skill set of understanding a business context, of understanding how to communicate really clearly, and of having kind of high-level insight into what kind of models are going to end up producing robustly similar results to the bottom-up models. In other words, how are we going to get a simple, easy to talk about model that captures most of the value of these bottom-up models, that captures most of the insight, but can actually be actioned in our space. So it's almost all, you have to have this kind of like very, very strong technical expertise, but almost all of what you're really doing requires communication and understanding the needs of your businesses. So I'm just going to sum up by saying some of the lessons that I have kind of learned here. One of them is that often the best outcomes you actually get from a well-chosen bad model. So you have to know the strengths and weaknesses of your model. You have to know which of these simple models is going to get you to what you want and get you to accurate views on the data. You have to understand how to use them. And one reason that this is a really good strategy, and I want to emphasize it, is you have to remember the uncertainty in what you're optimizing toward. We have all these great techniques for optimizing toward a particular sample, for optimizing toward a particular optimization function. You say, okay, I know what I want. I can get some model that captures that very, very closely. But even when you use these out-of-sample techniques, you're often getting an out-of-sample set drawn from the same set as your sample set, right? So you're getting viewing in 2019 and your model fits it really, really well. And you know that because of your out-of-sample set that you sampled in 2019, your model works really well for them, but you're trying to predict viewing in 2024, right? And so you don't actually have the right data to optimize toward. And as a result, losing a little model accuracy, fine, it's not that big a deal, as long as you know what accuracy you're losing and how. That's a really, really complicated lesson that it took me a while to learn, but it's been really, really powerful. Another really easy one is visualize all your data because you want to know what it's doing. And then I'm saying take the natural born cyborg approach. This is a reference to Andy Clark's book, Natural Born Cyborgs. The intuition, in short, is that we are all constantly working with artificial devices, from glasses to laptops to models. Instead of giving a model that says, here's what you should do, the best models are often ones that people can integrate themselves with so that a person can become a better decision maker by being connected to your model than they could be without it. They're still the decision maker. They're still doing what they want to do. You're not telling them what to do. You're saying, you and this model together, you're going to be so much better than you were alone. And then the last thing I'll say is, I think if you are especially at a starting stage where you're going into this kind of program, there's a ton to learn. It gets better, you get the hang of it, and it gets to be a lot of fun out in the world. All right, I think I want to make sure there's time for questions. So I will just assert the last part of my talk, which is in very, very brief form, it is great to be coming from a non-standard background like psychology or archaeology. Economics is a little less non-standard for us, but really coming from these backgrounds is super helpful. And the main reason it's super helpful is it gives you a different perspective, right? We really think these days in hiring at these companies about additivity rather than about fit, right? Are you giving us something that we can use and that's different from what we have? And that can come along a lot of different dimensions, but it can often come along a skill set sort of dimension. All right, I will stop there and turn it over to David for some comments and some questions. Thanks, everybody.
Thanks so much. And I'm going to share my screen just as one quick comment. David is one of the folks that we have engaged to act as an advisor to some of the material that we are developing in this program. And he's given us some of his insights, and that is feeding into the curriculum that we're trying to develop in the Master of Professional Studies in Game Entertainment and Media Analytics. And I'm just going to do a quick overview of our program. For those of you who are not that familiar with it, it is focusing on how analytics and data science can be applied in the game, the entertainment, and the media industries. And why did we focus on this? We built this program because we realized that literally there's no business like show business, and annual global entertainment revenues are growing in the trillions. Over half of the adults in the United States are video gamers. Video game and esports revenues are huge. And they're continuing to grow. But this number 4 bullet point, I think, is one that touches upon what David was talking about today. Streaming video on demand is projected to grow at an annual growth rate of 10% to 2025, which makes it also a huge industry in the United States, but also globally and worldwide. You can see this by the proliferation over the last couple of years in over-the-top video streaming services and the way that they are marketing, the way they're developing, and essentially the way they're competing, because there's only a limited amount of time that somebody can sit in front of a device and watch. And so they have to be smarter and smarter. And as David showed, also have to be sensitive to the needs of all aspects of the viewer and consumer communities. And so game entertainment and media companies are increasingly wanting to attract and hold on to customers' attention. And analytics actually in these contexts, over the last couple of months, I've had a number of conversations with a bunch of different people across the campus who are looking at being able to make use of the same types of techniques and skills and capabilities that we're training our students in, to apply the same techniques in terms of blending interactivity and understanding how people behave and how they make decisions. And it very much maps to the game and the viewing and the communication aspects of these types of industries. So arts, humanities, public health, had a conversation with folks who want to look at how games can be used to understand public health issues, national security and intelligence. Certainly there's a lot of folks who've been doing work in gaming for education and video for education. And if you look at a company like Khan Academy, a large amount of their focus is developing content and producing that and getting an understanding of how that content is being used and viewed and et cetera. Vocational training, political science, had a conversation with somebody about a week ago about that, the use of medicine, the use in city planning. These are all different areas where the types of skills that we are training folks across our curriculum can have applicability, not just in the entertainment business itself. So what is the program? It's a 30-credit, fully online program. It's a Master of Professional Studies. Like David, we have other experts in the game and entertainment industries that are giving us some guidance, folks from other streaming services and other large networks, folks from large gaming companies, folks from companies that do simulation tools, et cetera. And the program itself focuses on the application and use of information management analytics and data science for understanding how customer and player behaviors can improve the overall experience, maximizing customer lifetime value for monetization purposes, understanding telemetry analysis to how that can influence things like game design, but at the same time raising awareness of ethical data use and ensuring protection of private customer data. So what will you learn in this program? Well, students are going to learn about the entertainment and games industries, the data science and analytics lifecycle, problem solving in the context of the industry. And again, thank you, David, for highlighting that particular aspect of this, which is not about how do we throw technology and come up with lots of meaningless or useless results, but rather what are the types of challenges we're trying to address and how can we make use of the tools and technologies to solve those business problems. Customer profiling, user behavior analysis, churn/retention analysis, telemetry, compliance management, fairness, data ethics, and then inclusion, equity, and diversity within these contexts. And folks we are hoping that our graduates will be qualified to take on roles like a data analyst for game analytics or game data scientist or manager, data engineering or lead data scientists or content scientists, et cetera, director of data. We've seen these types of roles that have been advertised, and we're reaching out to other folks in the industry who have these titles and roles, and we're also seeking to make connections and network within the industry as well, so that we can have opportunities for experiential learning for our students when they reach that capstone stage. Why the University of Maryland College of Information Studies. Here's just a slide that highlights some of the key aspects of the school itself. I'm not going to read through this, but rather I'm going to point you to our website, which is ischool.umd.edu/gem, GEM, or you can email me directly, dlotion@umd.edu. And I'm going to leave this up. It's amazing. We got a bunch of great questions. And so, David, I think we still have, if I check my clock, it looks like we still have about 10 or so minutes. If you can answer these questions in like a minute each. I don't know if we're going to get to all of them. I'm just kind of kidding. But first question came from Pratik. Is there an interesting story with data science helping Netflix with Squid Game? Absolute winner.
Sure. Thanks. Yeah, so that's a great question. And I would say something like this. Yes and no. With Squid Game, like with any big title like that, with any title that really breaks out, like we don't have enough data to know which titles are going to do that. We absolutely not. We were not launching Squid Game being like, well, obviously this is going to be a huge global hit. But what we are doing is often thinking about, okay, what's likely to be in that? What's in the breakout pool, as it were? And I would say with Squid Game, it was in the breakout pool. Like it was one where it was a possibility and where we're sort of thinking like, oh, I wonder what'll happen with this. So I would say we kind of projected that and we knew it. And sometimes we can do things like place a title a little bit differently if we think it's in that pool. I don't mean on the service. I just mean we can make different box art. We can make, we can prep it in different languages or things like this. So we have to decide how many languages are we going to get something dubbed into, for instance. But actually, yeah, Squid Game, all those titles, whenever they really break out, it's a surprise. And we're scrambling after the fact to say, oh, okay, this is the one. Okay. I guess I'll also say one of the things that we could start to do was understand who was liking Squid Game. One of my favorite examples is, we started to see signs in our data that kids were watching Squid Game well before we started to see that out in the world and in communities. And it was very speculative, it was very guessworky, but it was something that we could start to think about. And then what we ended up having was people sometimes like playing games on the street saying, oh, I'm playing Squid Game, and they meant red light, green light. So there was some popularity there that we could kind of understand. And I should say, it is a very adult-oriented title. I do not recommend letting your kids watch it, but I'm also not controlling what anyone else is doing.
Thanks. Abby, who's a friend of the program, also who's come and visited some of our other webinars as well. Abby asked, do you find user interviews, surveys, et cetera, helpful in addition to tracking user watch times? Which data collection methods are your favorite and least favorite? So that's a great question.
That's a great question. The first half of it, Absolutely. Yes. We have teams that do focus groups, that do user interviews. We sometimes do surveys even on the platform. We certainly do them off the platform, and they're fantastic. And I'll say, at least in my experience at Netflix, those teams are really sharp. They're really invaluable to what we do. And they often help us understand what's going on in our data. I think of it, I don't have a favorite or least favorite. I love all data collection methods. What I would say is often what happens is we get really deep understanding from doing these user interviews and these survey methodologies. What we get from doing data science on the sort of big data science I've been talking about is we get scale. So we can do it across all of our countries. We can do it across all of our members. We can do it across all of our titles. So it's often less insightful and less accurate, but it's very scalable. And then there's often an interplay where we can suggest to them questions to ask. They can suggest to us interpretations. So there's kind of this working together that makes the whole thing work.
Yeah, that's great. That's an interesting point, especially in terms of being able to merge different types of results that are coming from different data sets that might cross different spectrums of user behaviors. We got another great question from Pratik, who has asked a bunch of good questions. I feel trailers and snippets are an important part of a viewer's decision making to go ahead and watch the content. How's the correlation between trailer versus actual movie series data analytics? Another great question.
That's a great question. Yeah, absolutely. What I guess I'll say in response to that is, certainly for us at Netflix, it's something that we look a lot at. I think there's some really great articles on our tech blog about some of the processes by which we do that. But it absolutely is the case that we are always looking for matching our members' expectations, right? Obviously, you want to put your best foot forward. You want to say this is a great title, but actually one of our big concerns is often when we want to say to people, actually, this title might not be for you. So how do we communicate that? Because we don't want people jumping into our title and not liking it, right? So it's a matter of trying to make that fit work so that we're saying, if you're gonna watch it, you might or might not know that at the outset. We might or might not know that at the outset. We want to give you an opportunity. But we also want to make sure you know things that might be blockers for you. And I think it's a constant interplay in thinking about our content. I guess I'll say one other thing that I was around for was there was some circumstance where one of the things we'll do is we'll make box art that has a particular actor in it who's in the title, because people are fans of particular actors and they want to watch something. And that has sometimes been a case where we've been guilty of ending up, not deliberately at all, but kind of accidentally misrepresenting titles, right? So we might, for instance, highlight a particular actor who's in the title who is Black, and the title has no other Black people in it. And then we've actually had cases, if you look, you can find a lot of historical public conversation about individual cases where people felt pretty reasonably that we were misrepresenting titles. So we spent a lot of time thinking about, okay, how do we learn from that, and how do we grow, and how do we make sure we're really like representing our content well? And there's a ton of data science that goes into that.
That's a great answer. Thank you. Before we go to the next question, I'm just going to remind our audience that today is March 17th. The deadline for applications for the GEM program is June 1st. But we are doing a rolling review of applications. So if you are thinking about applying and want to get ahead of the curve, certainly don't delay in starting and completing your application for the program. So let's go to the next question. How did COVID affect watching behaviors? Since people weren't having watch parties or in-person gatherings as often during that time, I'm curious if you noticed different watching patterns in the data.
We noticed so many different watching patterns in the data, honestly. And I guess I'll say this is a great example of a place where there is a really long ingestion process where we try to understand the data. Like you're talking about watch parties or in-person gatherings. Those probably changed quite a bit. But the first things we worried about were, we were really in this uncharted territory. So we were even saying things like, does Amazon, Amazon serves some pieces of our pages. Does Amazon have enough capacity to run our new data sets? Do we have enough streaming bandwidth to actually serve? So we had this kind of moment, not where we thought we were going to break the internet or anything like that, but where we thought we were going to break our processes. And we needed to understand that because it really was just a new time and really different things happening very quickly. So that was kind of our immediate questions. And then absolutely we noticed different watching patterns, and they're very challenging to interpret. So we put a lot of thought into that. We also, fortunately, things are always have been shifting and been in flux since then. So in some sense, there's a question of how much utility there is in looking at some of the details from that period, since hopefully that's not a period we have to be prepped for.
That was great. We have one last question. In the future, with the help of deepfake technology and programmatic scripts fed to artificial intelligence, is there a possibility of beginning non-human content creation?
Sure. I mean, in principle, yeah, absolutely. I'm very bullish on the long-term idea that all of our jobs will eventually become irrelevant. What I will say is right now, those are so terrible that I don't think programmatic scripts are not a thing that I have heard of anyone using in a serious way at any company. Analyzing scripts, there's a lot of work in, right? That's where we are right now, right? We're understanding scripts, we're understanding aspects of them, that's great. And in terms of deep fake tech, there's a business right now that is selling deep fake dubbing into other languages so that you can get dubbed content from an actor, but you get the actor's voice dubbed into a different language. That's the kind of application that I can see being much more near-term useful personally. But absolutely, who knows? You know, you never know when this stuff will really become applicable. So what I'm saying might be out of date by tomorrow, or might be true for a long, long time. All I'll say is right now, I haven't seen a programmatic script I was interested in.
Thanks. So again, a big thank you to David Landy from Netflix, who was kind enough to spend some time giving us a great insight, or a great set of insights into how analytics and data science are being used in streaming content. So thank you very much. Again, a reminder, get working on your applications for the Master of Professional Studies in Game Entertainment and Media Analytics. And then in a few years, you could be doing the same kind of stuff that David was talking about today. So thank you very much, Sarah. Thank you for helping out. David, again, much gratitude to you. And I think we're going to, we will make this video available. So for those of us who did not get a chance to join live, you'll get an opportunity to view it at a later point. So thank you very much. And I think that will conclude our program today.
All right. Thanks for having me, everybody, and good luck with your futures.